is Florent Mathieu, and I will show you how JMP Pro can help you for patent intelligence. Patent intelligence is very strategic for the development of new processes and new products. But this task is often a tedious job because reading patents is very hard work. For those who have already read a patent, they know how unreadable a patent is. So, the less you read patents, the better it is for you. And this is exactly where machine learning can help you. Using JMP, we'll try to mimic Netflix. Netflix, based on which film you have already seen, suggests you which film you will like. For patent intelligence, it's quite the same thing. So, based on which patent you already read, we will try to predict which patent you have to read. Before I will show you how to do that with JMP, I just want to introduce the case study that I work with patent intelligence and machine. And we can go. So, Michelin is a well-known tire manufacturer that aims at producing best-in-class performance tire. But now, the new leitmotif of Michelin is still to produce the best performance tire, but this time with much sustainable materials only. And a tire is made of plenty of type of materials, such as natural rubber, plastifiers, charged synthetic rubber, and so on. For now, almost none of these raw materials are sustainable. They all come from fossil resources. So the aims at Michelin is to produce new chemical processes that will produce these new sustainable materials, which means new processes means patent intelligence. The case study on which we'll talk about today is about the producing recycled styrene. The styrene is used in synthetic rubber. To recycle the styrene, what we do is to collect polystyrene waste, and then we have to precondition the polystyrene to remove all the impurities, and then we go to this process, which is developed with our Canadian partner, Pireway. And our process is composed of three main parts. The first is the liquefaction of the polystyrene and the removal of the impurities. Then we put the polystyrene in an industrial microwave. The microwave is not the kind that you have in your kitchen. I mean, it's an enormous microwave. And this microwave will cut the polymer chain into small pieces, I mean, into styrene monomer. But at the exit of the reactors, the styrene monomer is not pure. It contains a lot of aromatic materials. So we have to purify it, and we do that by distillation. At the exit of the distillation, we obtain recycled styrene, which has the same properties as fossil styrene. So we can use this recycled styrene to produce many kinds of objects containing polystyrene, and especially tires. So this is a very innovative process, and we need a lot of patent intelligence. But patent intelligence have two issues. The first is expertizing patents take a lot of time, and only few patents are analyzed. The second issue is that we strongly depend on the search engine and keywords. So imagine we want to search for patents on our process. We will type some keywords on Google Patents or PassNap or Byte, whatever. And what we will read is only the first page of the search engine, and very rarely the second page. But that is sure that we won't read all the patents that appears after the second pages. So there is a high risk of missing a very important patent. That is why we need a tool that will read for us a high amount of patents. And that's what we will do now with JMP. So I switch to JMP, and I will show you how to do that. So here is the table that I imported from Orbite. Here we have the patent number, so it can identify each patent. We have the assignees here. We have here the title of the patent, the abstract that describe what contains the patent, and the claims. And for all the patents that we have read, we tagged the patent if it's critical or not. So the idea is now to try to set up a machine learning model that will predict if a patent is critical or not. And this table has two parts. Patents that are manually expertized, so patents that we read, and some patents that we haven't read. So we will use this second part in the second part of the presentation. For now, as we will build up the model, we will exclude this data that we haven't read. So the first thing to do is to use the Text Explorer. So we will focus on abstract only for this presentation, but of course we can use claims and title and whatever. We will use the ID here, the publication number, and here we say, okay, just few settings. English, we say the minimum character per word is 3. We will use stemming, and I will tell you what is stemming just later. And here we will use basic words. So now I just have to launch the Text Explorer, and here is what we have. On the left part of this screen, you have here the list of the terms that JMP Pro has read in the abstract column. So here is the frequency of each term appears in the whole column. And here you can notice what is stemming. For example, for materials, if I jumps say, okay, material and materials is the same meaning. So it groups all the word by the root of the word. On the right part of the screen, what we have is phrase. Phrase is 2 or 3 or 4 words that can have a meaning. Okay, for example, pyrolysis oil has a meaning, and the meaning is different if we separate pyrolysis and oil. So what we do is to select the phrases that has a meaning, which is interesting, and we can say, okay, add phrase. Now what we have, JMP consider phrase as a term. For example, this one, hydrocarbon stem, is now considered as a term. We can do some more cleaning. For example, provide. Provide does not give you information on the patents. So what we can do is right-click and say, okay, this is a stop word. So I don't want to take provide, providing, or whatever in this analyze. So we removed it. With JMP Pro, you can manage all the stop word on all the phrases here. And as you can see, all the stop words are stored here in local. But if we want to set it by default, we can just put it in user. So I do not have to exclude that word each time I will use the Text Explorer. I can also export and import all the stop words, phrases, and record. Now, the first tool that we will use to analyze patent and try to predict if a patent is critical is term selection. So what we want is to predict if a patent is critical or not. So I want patent critical. Here is some settings, and the only setting that we will change here is to use log frequency of term instead of binary. And I click on Run. Here we have the first model. And here the result of the model are here. So what we can do, see, is the R square is not that bad because it's almost 0.5. The misclassification rate is also very well. I mean, less than 1% of the patents are misclassified. So this is pretty good. Here we have all the terms that the model used to predict if the patent is critical or not. And we can sort it by the most important term to the last one. And if I click on polystyrene, which is not surprising, you can see all the patents where the word polystyrene appears. So it's very useful to understand how the model is built. On the left table, what we have is the prediction of the model. Here we can sort by the maximum probability of being critical. And if I click on it, I can read why a patent is critical for us or not. And then can compare if it's actually critical. And for those, okay, that the probability to be critical by the model is high, and actually it is critical. There is some patents that are actually not critical, but the model says maybe it could be critical, and we should read it, because maybe we were wrong when we read the first time, and by rereading this patent, we can find some misunderstanding that we don't the first time. So that's the first tool that we can do for patent classification and prediction. But from my point of view, this is not enough, because we are not confident if this model will predict well on data that he hasn't seen, if patent will be critical or not. So to do that and to improve also the R square, we will use another machine learning model. So to use machine learning model, what we will do is to export the documenter matrix, which contain all the numerical data. And in this DTM, each patent is represented by all the frequency of all that term. So I already did that before, and we will just have a look on the DTM of the abstract. So it looks like matrix, the sparse matrix, which has something like 400 columns. We can just use a cell plot to better visualize what looks like the DTM. So I only take the 20 most frequent terms, and here when it's green, it means this term does not appear in the patent, and when it's red, it appears a lot of time. Here in blue, you have the critical patent. And if I click on critical patent, the aims of the machine learning model will be to understand which pattern leads to critical patents. And before using machine learning model, we'll have to do two things which are very important. The first thing is the data are very imbalanced. I mean, the number of critical patents is very small compared to the number of patents that we have read. So it's like searching a needle in a haystack. So we have to rebalance all the data. To do that, what we did is to use a frequency column. So the frequency column has a formula which is inversely proportional of the number of times a patent is critical or not. And the second thing that we will do is to use a validation set. Using validation set, we will have better confidence on the predictability of the model. So once we set up frequency and validation, now we have pretty good data, which has balances and a validation set. Now we can launch a machine learning model. So I will use first the neural network. The first thing that I want is to predict if the patent is critical or not. I will use as factors the DTM. I do not forget to use the frequency to balance the data, and the validation column to be sure that the model is predictable or not. So let's go. Now I will just configure some hyperparameters, and we will use boosting. And that's all. Now the model is fitting. So we'll just wait a few seconds to have a model. And here we are. So that's the first model. If you remember the R square that we had on the first model, it was 0.5. Now with this neural network, we have 94 as R square. And for the validation set, we have 0.86. So it's a big improvement. The misclassification rate is quite the same, but we have rebalanced the data. So now it is pretty well. Here we have the confusion matrix, and you can see that actual patterns are predicted as actual. And for the validation set, that's the same. So almost unknown fault. So now what we can do is to save the formula of the model, and I have already done that. Here is the formula, and the formula predicts the probability to be critical or not critical. So we can now re-include all the data that we excluded to apply this formula model on patterns that we haven't read. So we just wait for them to calculate the probability. Here we are. So we can see the prediction of the neural network. So here is what we have. On blue, it's the patterns that we have read, and in diamond, the patterns that are actually critical, and in orange, the patterns that we didn't read, but the machine learning model has read for us. So as you can see, the probability to be critical predicted by the model for all the critical patterns is pretty high. So the model does a good job. Now, if we want to know which pattern to read, we just have to select those patterns and take a subset of it. And here we have a short list of very important models. And here, if you see which kind of patent we have a lot of patents that are important for us. And they speak about styrene purification, or I don't know, maybe this one, which is recycled styrene monomer. So that patents are very important for us. And when we read all these patents, in fact, we had very good surprise, and many of those patterns is critical for us now. But sometimes it could happen that the model is nonsense because the word that was used for the model aren't precise, and maybe a good thing is to set up a different kind of model. So that's what I did. and I set up model like Lasso, Boosted Tree, or neural networks that take into account not only the abstract, but also the claims, the title. We can also include IPCs. And I did an awesome model, which is an average of all those patterns. And now the selection is more precise, and we can also see what patterns we have in this subset. Now the chance to be very critical is very important, and the number of critical patterns that we have to read is smaller than with only one model. So we increase the performance of the machine learning model. Now, let's go back to the presentation. So what we did is we imported data from Orbit Intelligence, we converted into textual data, and we set a machine learning model. So here is a method that we use, detailed method. So we did manual ranking of patterns on the small corpus by hand. We cleaned up and import the data into JMP. Then we converted the data, the textual data, into matrix. We created a validation set. We rebalance all the data using frequency field. And then we use several machine learning models, such as Lasso, neural network, boosted tree. And we did an awesome model that averaged all the supervised machine learning models that we set up. That was the first step. And the second step was the production. So we use that model on a wide corpus of patterns that we had them treat. We clean up and import all the patterns the same way as the first step and converting, and we do some prediction. Now we are able to select only a few patterns that are probably critical, and the number of patterns that we will read is quite small, and we have a high chance to read only critical patterns and to spend time on the good patterns. So the conclusion of this work is machine learning can automate time-consuming tasks. It's a tool that will help you, but under no circumstances it will replace human expertise. This methodology is very useful applied to patterns and could be probably applied to many kinds of textual data. Using JMP Pro, you will see that you have seen that it's very easy to do that, and JMP Pro is very performant for setting up machine learning like that. So what we can say is this machine learning model just mimic our choice. It is if we want to go further, or if we change our choice, I mean, if we include new patterns that are critical, either we will need to rebuild new model, or to have another approach which is based on deep learning on whatever. So I finished the presentation, and I hope you enjoyed it. I hope it will give inspiration for future work, maybe on patterns or any textual data. Do not hesitate to contact me on the JMP community or to post some comments. And thank you for watching. Bye-bye.